Our operations on functions are exactly what you would think if you were going to make up the rules yourself. If you were adding two functions together, one of them was 5x and the other one was x plus 2, you would just add them together. 5x's and 1x's is 6x plus the 2. If you were going to subtract them, you would do the same thing. The 5x minus the x plus 2. So you'd say 5x take away x is 4x, and take away 2 is negative 2. Same thing with multiplication. We just multiply them, we divide them. If it's division, it's exactly what you would think it would be. So if you don't try to overcomplicate it, just do what you would guess if you didn't know the rules. This is what we do here. When we add these together and when we subtract them, notice that we have 4 to the 1/2 and we have a minus, so we're really subtracting. Notice something here. The x to the half and the x to the half, it doesn't change. It stays x to the half, okay? It's like we're keeping track of dogs or something. We have, I don't know what negative dogs would be, but we have 4 positive dogs and 9 dogs, I guess, in a bad mood, negative. So there's negative 5 would win out because there's more negative dogs. And the x to the 1/2, that doesn't change. That's just dogs, you know. So it's just the coefficients in front that change. When we subtract, we're going to say, 4 to the 1/2 minus a minus. Now might as well say we're adding. Now we have 13. Does the x to the 1/2 change? No, not at all. I'm allowed to put them together because they're both x to the half. If they weren't both x to the half, I couldn't put them together. And there's nothing that's going to limit the domain, except that since x to the 1/2 is really the square root of x, right? X to the 1/2. The 2 goes out in front. We don't usually write the 2 in the square root. That can't be negative. So as long as they're not negative, okay, the domain is fine. We're allowed to put whatever we want as long as it's not negative. So let's go ahead and do ours. We say f of x plus g of x. So I say, well, I'll list out f of x. That's negative 3 to the 1/3 plus 4 to the x to the 1/2. These are not the same dogs, okay? We might as well say dogs and cats, and we can't add those together. So inside of f here, we can't add them together. Not going to happen. However, we're adding it to g, and so g has these over here, and I'm going to line up the 5 with the negative 3. All right. And I'm going to line up the 4 with the other 4. And since these guys share common terms, these are the same, so I can put them together. And these are not the same, but they're the same as each other, so I can put them together. And I have to keep them apart. I can't put these two together when I get done. What do I get? I get 2, because negative 3, positive 5, x to the 1/3, plus these are both positive, so 8 x to the 1/2. And I stop there. Unless, I could think of something else, but, I can't simplify anything more. So if there were some way I could make them, the same exponents, but there's no play here, so I cannot put them together. And somehow, look up here at the rules. Look up here at the rules. Do you see anything? Where are the rules? Did I lose the rules? Oh, the rules are up here. Do you see anything where I'm allowed to add? In fact, there's no adding at all. It's multiplying and power rule, and none of this is adding. So it's not on the list. Oops, it's not on the list. So therefore, I can't do it. So let's go ahead and let's subtract. We have the same thing. We'll write down f of x. This is f of x. Same as before. And now this time I'm going to subtract. So, I'm going to change the sign. I'm going to change the sign and add. That's the same as subtraction, right? And so when I add, I get negative 8x to the 1/3. Notice that the exponent doesn't change. And then these guys cancel over here. So that's it. That's my answer there. And the second part cancels. And then there's my answer to the first part.